Hello class 11. In this video we are going to discuss about a very important concept of something called conservative and non-conservative forces. So let us get started with the definition. So what is a conservative force? A force is said to be conservative, remember, if the work done by the force is independent of the path followed. Because whenever work is done, there is some displacement produced, of course, okay, because you have a body on which a force is acting. Now, work is said to be done when the force acting on the body produces some displacement of the body, of course, or so to say, makes the body move. So, the body therefore moves in a certain path. It moves in a particular path. So, we are saying forces are said to be conservative if the work done by the force, or could also be against the force, the work done against the force is independent of the path followed. So if the work done by the force or against the force is not dependent on the path followed, then we say that kind of a force is what is called a conservative force. Whereas non-conservative force, exactly the opposite. A force or forces are said to be conservative if the work done by the force or against the force is dependent on the path followed. Now, to give you an example of conservative forces are, the examples are gravitational force, electrostatic force, magnetic force, okay? Whereas non-conservative force example is the force of friction. So, whenever work is done by or against a gravitational force, or by or against electrostatic force, or work is done by or against magnetic force, then the work done is independent of the path followed. Alright? Whereas, of course, we'll talk about this too, the work done by the force of friction or against the force of friction is path dependent. Remember that. Okay, so let me give you an example of conservative forces. Let me take the example of a gravitational force, or simply, so to say, the force of gravity. Okay? So, for that, I have to erase this. So, you can quickly pause the video and copy this. Okay? So, let me erase, especially the lower half, that is non-conservative force. Okay. So, say we have a body having a certain mass m. The body has a certain mass m. So m is the mass of the body. Obviously there will be force of gravity acting on the body, mg. So mg is the force of gravity acting on the body. Now what we want to do is, we want to take this body from point A up to point B, displacing it, so to say, by a height h. So this body is at point A, I want to take it to point B, displacing it, so to say, by a height h. So how much is the work done in this case? And see, the path followed is this. Okay, so how much is the work done? The work done against the force of gravity, of course, in this case, because we have to move the body up against the force of gravity, will be mg into, that is the force, multiplied by displacement, since we are doing work against the force of gravity. So this is equal to mg h simply. And mind you, this amount of work that is done to lift the body from point A to point B, displacing it by a height h, is what is stored as its potential energy, and thereby the potential energy of the body at this point B, or so to say at a height h from the ground, is mgh. Okay, so that is another part of the story, but here we are looking at conservative force. Now what we want to do is, so this is one of the paths that we follow to lift the body from point A to point B. The other path that we can follow is by moving the body up the incline, still displacing it by a vertical height h. So the vertical height it moves is still the same, but in this case the path followed is different. So we are taking this body up the incline from this point to this point. So say at some point of time the body has reached this position, So its weight mg is acting vertically downward, and if the angle of inclination is theta, then we can resolve this weight mg into two mutually perpendicular components. We have done this so many times. So this component is mg sine theta, and this component is mg cos of theta. Now, which component are we interested in here? We are interested in mg sine theta, because to take the body up the incline, we have to do work against this component of weight, which is mg sine theta. So, the force acting in this case is mg sine theta. So, we need to do work against this force, mg sine theta. And what is the displacement? The displacement is this much. Okay, let me name these points A, B again. So AB is the displacement. We need to find how much is AB. Now if we look at this right angle triangle, then in this right angle triangle, sine theta is h by AB. So to say, from here, AB will be how much? H by sine of theta. So we get to see that the displacement, or in moving the body up the inclined plane, we are displacing it by h by sine theta. So this is the force acting, and the displacement is h by sine theta. So sine theta, they divide each other out. So therefore, what is the work done? The work done still is mg into h. Okay, so in order to take this body straight up, the amount of work we are doing is mgh. To take the body up the incline, obviously following a different path, the work done is still the same by this, because we are eventually displacing it by a vertical height h. The work done is mgh. Now we can still give one more example of doing work against force of gravity. That is, let me erase this example. That is, by taking the body up the flight of stairs here. Okay, eventually still displacing the body by a vertical height h. So the body initially is here. So this is mg acting on it. Okay, so let's try and see how much is the work done in order to take this body up the staircase, so to say, again following a different kind of a path. And by the way, one thing get very clearly, in all these cases that we've considered, okay, we are assuming there is no dissipative force whatsoever. Okay, there is no forces like friction when we move the body straight up or up the incline, or when we take the body through this, staircase. Okay, so there is no force of friction or any other kind of dissipative forces whatsoever. Now, let us assume that the height of each stair is h dash. H dash is height of each stair over here. Okay, and n is the number of stairs. Okay, so can I erase this part here? I hope you've understood. Okay, so therefore what can we write? We can write n into h dash is small h. We can write this. Okay, so in order to take this body from this point, understand it very clearly, from this point to this point, moving it by a vertical height h dash. So what is the work done? The work done is mg, the force of gravity, into h dash. Okay, now we also need to take the body through this horizontal distance, but the work done against the force of gravity to move the body by the horizontal distance is 0, because force of gravity and the horizontal distance are at an angle of 90 degrees with respect to each other. So to say, there is no work done to move the body by the horizontal distance. In every stair over here, the work done to move it by a horizontal distance is 0 against the force of gravity, of course, and we are considering no friction, the case of no friction. So the work done to move it up by one stair is mg h dash. So the work done to move it by n number of stairs will simply be mg h dash into n. So mg into n h dash, but n h dash is simply h. So we still see that the work done to take the body up the flight of stairs is still the same mgh. So we get to see that the work done by or against the force of gravity is independent of the path followed. Therefore, force of gravity is force of gravity, I almost said distributive force. Force of gravity is an example, therefore, of a conservative force, remember. Okay? Whereas, non-conservative force example is force of friction, like I already told you. If we had incorporated friction in all of the three different cases that we discussed, if there was friction, then here we have to travel longer distance and we have to overcome a lot of force of friction. So in this case, the work done would be more because we need to do work against the force of friction also. We need to overcome force of friction also. Okay? And in this case, the work done would be different because force of friction, the amount of force of friction here would be different. And of course, to lift the body straight up, the work done would be different because the force of friction in this case would obviously be different. So remember, force of gravity or gravitational force in general is an example of conservative force. Likewise, we can also see that electrostatic force and magnetic force, they are examples of conservative forces. Whereas, mind you, force of friction is a non-conservative force because the work done against the force of friction is path dependent. Okay, so this is the concept of conservative and non-conservative forces. Thank you.